Teaching platform. In this video, we shall look at how best we can evaluate a given polynomial function, but we will focus on a constant function. We are to evaluate the lim of 4 as x approaches 2. So it means the function here is a constant function. So we can write the y to be equal to 4 as the constant. Sorry, as the function. So let us look at it from this side. So we are going to have y is equal to 4. So we have to find the value that y approaches as its input x approaches 2. Now we consider that we have y is equal to 4, but there's no x over there. So how do we evaluate this polynomial function or this constant function since there's no x over there for us to plug in 2 in place of the x? So let us use a diagram to know how or to get how best we can evaluate any given constant function. So let us first look at our xy plane. We are going to use the xy plane to illustrate how best we can evaluate a given constant function. So I'll draw my xy plane here. So I have my xy plane. So my my x-axis will follow. So I have my y-axis, and I also have my x-axis. All right. Now let us draw the graph of the function y is equal to 4. Graph of the function y is equal to 4. So it means we are to indicate y to 4 on its axis where x is equal to 0. So here y is 4 by, so I'll indicate it by, then I'll draw my graph for the line y is equal to 4. So this is a graph for the constant function. All right. Now we are to determine the output, that is the y value, as x approaches 2. So let us indicate our 2 here. Let's assume that x is equal to 2 over here. So you can consider both the left-hand side and that of the right-hand side of the x being equal to 2. So let's start from this side. So let's assume that x is -1 over here. So if x is -1, let us look at its corresponding y value. So you can see that y is still 4. When x is equal to 0, and you trace it, you still get y to be equal to 4. Because when you trace it to the line, y is equal to 4, and you trace it back to the y-axis, parallel to the x-axis, you get y to be equal to 4. Let us take another number here. Let's assume that we have a number which is 1 here. So let's say x is equal to 1 over here. So we have 1 here. We have here to be 0 and here to be -1. Now let us find the corresponding value of x. So we are going to, so let's find the corresponding value of y as x is equal to 1. So when you trace it to the graph, we are still getting y to be equal to 4. So it means as x approaches 2 from the left-hand side, so as x approaches 2, we are still getting y to be equal to 4. All right. Now let us take it from the right-hand side of 2. So let us now take it from the right-hand side of 2. So let us say that here is 4. So you say if x is 4, and you let us extend the graph for the y is equal to 4. And you extend this one, we want to get a corresponding y value. It's still going to be y is equal to 4. If we get closer to 2, so let us assume x is equal to 3 over here. So if x is equal to 3 over here, now let us get a corresponding y value. And you can see that we are still getting 4. So we get to where the 4. So as x is approaching 2, we are still getting y to be equal to 4. So we conclude that the lim of 4 as x approaches 2 is still equal to 4. So this should tell you that anytime you have a constant function and you are finding its limit as its output approaches a certain number, the limit of that function is the same as the function. So the limit of, let's say, -6 as x approaches 2 will still be -6. The limit of, let's say, k. So let us get the general form of what we have just done. So if you have, let's say, limit, you have your limit, let's say you have your limit to be k as x approaches a certain number. So I've used c over there. So it's going to be k. So anytime you have a constant function, so yeah, where k is a constant. So anytime you have a constant function, and you have to find the limit of that function, the limit of that function as its input approaches a certain value. That limit becomes the same constant. So we are going to deal with more examples in our next video, but let's just consider at least 2 examples before 2 more examples in this video. So let's just assume that you have to find the limit, you have to evaluate the -6 as x approaches -2. So based on what we just did, you could say that this is a constant function, so it's just going to be, the value will be -6. We don't need to even substitute any value to any function. Just pick the constant as the name of the function as its input approaches -2. Let us take another one and see. Suppose you have lim as, let's say you have lim 1/6 as x approaches -1. This will still give us 1 out of what? 6 to be the limit of the constant function 1/6 as x approaches -1. Let's take the last one. So suppose you have lim of here to be q. Let's say we have q over here as x approaches c. So if you have this as x approaches c, you could see that there's no x multiplying this. So this is considered to be a constant. So the limiting value of this linear function, of this constant function becomes q. So you just pick the constant part, and that becomes the limiting value of the function y is equal to q as x approaches c.